Hi there, thanks for tuning to my channel. My name is Abatan Sheriffdeen, and I'm a top rated plus freelance data analyst on Upwork. Welcome to my live stream. So, I'm currently on a journey to live stream for the next 100 days and also learn SQL on Datacamp for the next 100 days. And luckily for me, I've been on this for the past 17 days consistently showing up for 30 minutes on live and offline. I do a lot of practice after the live just to cover more areas before the next 100 days. So if I take a couple of lessons today, today would be my day 18th learning streak. So welcome to the channel. And if you are looking for ways to become a successful freelancer or looking for the best resources to learn how to freelance and be a top rated plus top one earning percent freelancer in the world, you need to check out a course by my coach, Being Adebi, in the YouTube description. The course is called FCM Freelance Clients Magnet Course, which teaches you how to become a successful freelancer on Upwork, Fiverr, LinkedIn, remote job website. So if you combine these four platforms, you surely have major success in one, two, or almost all of the platforms. You also learn about pricing and the strategy you can use to price premium for your freelance skills, for the value you are providing to the clients. You get that? And also there is also a community of freelancers willing to share their knowledge and to help you grow. Also, you also get pricing strategy and one-on-one weekend coaching from the course instructor himself, Benga DBE. You can check out Benga DBE in the YouTube description. I leave a link to his Twitter account so you can check him out there to see a lot of testimonials from successful freelancers all over the world. So without further ado, let's jump right to today's lesson. So every day before I begin a new lesson or continue where I stopped from yesterday, I get to practice and review the weak areas. So today I think I only have just one weak area, or let me just refresh that. If I refresh the page, I think I have just one area to review so far. Let's review that together. I'll just start review that quickly. So the average male height in Europe is 178 centimeters. The players table in the database includes data on each player's height. How will you categorize them as above or below the average in SQL? Oh, okay, that's cool. So I think they've already calculated the average male height in Europe. So if you want to say select player name, mm, okay, so I say case when, to say yeah, select player name, case when height is less than or equal to the average, you can say then below average, that will be then below average. You can also say, oh, it should also be a case. Okay, else, you can say else above average, and as height from players limit 5. So that should be correct. And boom, so that's correct. That is a simple case statement there. Just one case statement. So the average European male is 117 centimeters with a standard deviation of 10 centimeters. We players are one standard deviation taller than average. Complete the code to return the output. Select player name and the height. Case when, okay, you can say case when height is greater than 188, then store, else not store end the type category from players where that should be where height Now, where height is greater than that, let's check that. Oh, cool. So select the code to return the output. We have the ID, the date, the awaiting. We are selecting ID. So that should be select ID and date. So this should be correct. This is selecting country ID and date. This is wrong. ID and date. So the answer is between this first option and this last option. Yeah. Let's see the difference. So when ID is 9823, we have 9823, then Bayern Munich. When awaiting ID is 98, let's check this one here. We have FC Schalke here, then VFP Stuttgart here. Okay, hold on. Let's see FC Schalke here. Oh, this will be the answer. Even though I'm not visualizing the table here, I can see the then clause there showing what happens if you exclude else clause from your case statement. Mm, if you exclude else clause, you can't leave out the else clause. You can't. You get further by default, you get an error, you get no values, but I think you get no values by default. Yeah, so when you exclude the else clause from your case statements, but when you're doing like complex case, you get no values. So how can you calculate an average of goals scored in 2013-2014 season from the season's column without a filter in the where clause? Without a filter in the where clause. So how can you calculate the average of goals scored in the 2012-2013 season from the season column without a filter in the where clause? From the season column, average goals scored. Hmm. Try code. So I need to type the code. Okay. Hmm. From country I see left join match and then consider go by so let's see that name as country. Say case, that should be case. Okay, so that the average. So we start with average and case when season is when season. That's when the season. So the average when the season is equal to this, then home goal headers home average. So it's going to count when the season. How can you calculate the average of goals scored in the 2020 from the season's column without a filter in the way of clause? From country and see left join average case when season is equal to this. So let's see. Required output country. Oh, I got it. Portugal, France, and Scotland. So it's pretty simple. So without you don't need a filter anywhere close. You could just say average case when. So the case when is going to count each rows from that shows each rows from the season column that met the 2012-2013 season. So when you count that, you just go to the average home goal. So just as home average, name as country from country FC. Then join match of AM1C of course I go by. I'm trying to visualize how the table looks like. But I know that you just need to case when the season, when it comes to the 2012-2013 season, then it should just return a new column called average growth. So after counting each rows that made the criteria from that season column, from that particular column, so you just go to the goals table and calculate that. So that is a bit complex, but that's how it is. Cool. So we are on learning day 18. So I'm super excited, and let's see how it goes when this is actually showing the 100. My network is not pretty strong this morning. So cool. So I'm done with today's review. And I've done it in this lesson, but let's do more. So that's just a review section. So I think yesterday I completed the chapter 2 of this data manipulation. So I'm moving on to chapter 3 now. Because I've completed chapter 1, chapter 2. So I did a couple of sub-queries yesterday. Because I think I did adding sub-query in select, adding sub-query in form. So I added sub-queries from select, form, and where. And I was able to do it myself, getting 100% mark. Because the last 3 queries challenge, I got it correctly without peeping on the answer. So you have to try as much as possible to solve it yourself without showing the answer. That really means you understand the lesson. So I'm moving on to chapter 3 in this data manipulation section, which is correlated queries, nested queries, and common table expression. I look forward to this Windows function. I've never used any of them before, I think. So let's continue for the next 20 to 25 minutes.
Welcome back. You're making fantastic progress so far. Now that you've covered the basics of simple subqueries, let's learn how to construct correlated subqueries. Correlated subqueries are a special kind of subquery that use values from the outer query in order to generate the final results. The subquery is re-executed each time a new row in the final data set is returned in order to properly
Correlated subquery use values from the outer query to generate a result. We want for everybody know in the final data set.
generate each new piece.
That's starting to sound scary. It gets more complex, I guess.
Piece of information. Correlated subqueries are used for special types of calculations such as advanced joining, filtering, and evaluating of data in the database. Let's walk through an example of one of these queries. In the previous chapter, you completed an exercise that answered the question, which match stages, where the stakes get higher in each stage, tend to have a higher than average number of goals scored. You achieve this using 3 simple subqueries in the select, from, and where statements. However, that same output can also be produced with a correlated subquery. Let's focus on the subquery in the where statement. This query only has one difference. Instead of including a filter by season, the where clause filters for data where the outer table's match stage, pulled from the subquery in from, is higher than the overall average generated in the where subquery. The entire where statement is saying, in essence, return stages where the values in the subquery are higher than the average. Here are the results generated by this query. This may seem a bit complicated, but with a few more examples and a bit of practice, you will start to get the hang of how useful correlated subqueries can be. Let's quickly walk through some key differences between simple and correlated subqueries. Simple subqueries can be used in extracting, structuring, or filtering information and can run independent of the main query. In contrast, a correlated subquery cannot be executed on its own because it's dependent on the values in the main query. Additionally, a simple subquery is evaluated once in the entire statement. A correlated subquery is evaluated in loops, once for each row generated by the dataset. This means that adding correlated subqueries will slow down your query performance, since your query is recalculating information over and over. Be careful not to include too many correlated subqueries, or your query may take a long time to run. Here's another smaller.
You say be careful not to include it. I won't include it. Since you slow down the system, why should I use correlated subquery? It's good to know
may take a long time to run. Here's another smaller example of a query in which you can use a correlated subquery. Let's answer the question, what is the average number of goals scored in each country across all match seasons? This is an easy enough question, right? You simply join the match table to the country table on the country's ID and extract the country's name, take an average of the goals scored, and group the entire query by the country's name, yielding one row with an average value per country.
That is pretty straightforward. You just select the home goal plus the away goal, then you get the average. As average goes from countries. So you just join it to the match table. Join to the match table. That's pretty straightforward. Just get the average goal scored for each country,
yielding one row with an average value per country.
Let's see correlated subquery.
A correlated subquery can be used here in lieu of a join. Take a look at the outer query first. The name of the country is selected from the country table.
Name as country. So this is a correlated subquery. Select average on goal from match as M. Where country is. Okay, so this one should run first. We're going to get just okay. If you should run this select average on goal plus away goal from match as M, where country ID. Even though from the beginning, so you're already joining the country ID to the match ID, the match table to the country table, where plus. I think that's possible, sure. So you just get the average home goal like you got earlier. Where now instead of using joins, we're now using correlated subquery. That's interesting though. We'll do an example now.
Aliased as C. The second column selected is a scalar subquery, selecting the average total goals scored across seasons from the match table. You'll notice that the where clause asks SQL to return values where the inner match table's country ID column matches the c.id column in the outer query's country table. This way, the entire join is replaced and the results are identical. Okay, it's time to practice using correlated subqueries.
So in essence, we are skipping using joins rather than just using where clause. Okay, let's do an example and see. This is loading. Okay. So basic correlated subqueries. So collectors subqueries are subqueries that reference one or more columns. Yeah, just like in the main query. Okay. Collectors subqueries depend on information in the main query to run and thus cannot be executed on their own. Wow, so I can't even execute it on my own. I was thinking I could execute it before the main query. So correlators of queries are evaluated in SQL once per row of data retrieved, a process that takes a lot more computing power and time than a simple subquery. So in this exercise, we will practice using correlators of queries to examine matches with scores that are extreme outliers for each country, about 3 times the average score. So select country ID, date, home go, and away go column in the main query. So this is the main query. I have to make sure I'm selecting it from where. Select country ID, date, home, and away go from March. Okay, from March, I need to specify time here as, wait a minute, from March. Complete average value in the subquery. Complete the subquery column reference so that the country ID is matched in the main and subquery. That's tricky. From match as main, okay, match as the name as main. This is right, type main here. Main. The country ID, date. This is date. That should be main dot date. Then main and home go and away go from March. Main dot home go and main dot away underscore go. So that is less from March as main. Where filter the main subquery by the filter the main query by the subquery. Where home go plus away go is greater than 3 times this subquery. So now I have to select the sub.away go as sub. So these are the name as sub. Still the same from March. So this will be set average sub home go plus sub away go times 3. So set the query for March as sub. Join the main query to the subquery. So the main query will be joined to the subquery on definitely the country ID. Definitely the country ID.